to record this way, just so it's like a screen capture for anyone who does it online. So I'm hoping the video will be easier to watch, because I'm assuming this video is going to be rewatched because it's a tricky concept today. Okay, so it's just screen capturing what I'm saying here. So, I think so. I don't know. But can we get going? Can you guys stop talking to your neighbors? Okay. So, guys, shh. So on the board, for the warm-up, we reviewed implicit differentiation. Today, what we're going to do is we're going to talk about how to solve a differential equation. All that means is I'm finding the antiderivative of something that was implicitly derived. So like the opposite process of what we did on the warm-up, okay? So if I'm given dy dx equals, we're going to start with an easier one, x over y, can I antiderive something that has multiple variables, right? So to get something like this, we would have implicitly derived, right? That's the one where I multiply by the derivative coefficients. Does that make sense? So today we're going to learn the antiderivative process of that, okay? Now, when these show up on AB Calc tests, which is almost every time one of the FRQs, they're usually 5 or 6 points each. So this is usually a big one, okay? Lots of algebra today. So we all wore our algebra pants, yeah? Yeah, okay. Spencer checked, but is it all right? He's like, I think, oh man, those weren't in a wash. Okay. So there's two types, guys, listen, there's two types of problems we're going to deal with today. The first one is called a general solution. Okay, so a general solution.
So you call this finding the antiderivative of...
It's general and particular solutions of differential equations. It's what I have written up there. So, but it's finding an antiderivative of a differential equation, which is what we call these ones that have an x and a y in it. Okay? So we've got general solution and we have particular solutions. Think about what those words mean, like in English, right? Particular is like a specific one, and general in general. So a general solution is still going to have a plus c in it. A general solution means I'm still being represented by the infinite possible antiderivatives. The particular solution we'll do a little later. Those are the ones that I am given more information about the original graph, like an initial condition point, and I can actually find what C is and find the specific answer that I'm looking for. Does that make sense? Okay, so general will still have the plus C. It represents an infinite number of possibilities. Particular means I have maybe more information and I can find a specific answer. So there's no more C, okay? So far, okay? Yes. Okay, the very first step always for stuff like this is what's called separating the variables, okay? Very first step is called separating the variables. So the idea is that I don't want to integrate something with more than one variable in it. So I need everything with an x on one side and everything with a y on one side. But the caveat to that is that if I'm going to integrate, I can't have a dy or a dx in a denominator, right? So that means that tells me that I should be putting my y's on the left and my x's on the right.
Wait, say that again one more time.
Okay. So the issue when I separate the variables, meaning getting all the x's on one side and all the y's on one side, is that if I'm going to integrate, I can't integrate something like that. I can't have my d's in the denominator, right? So that tells me I'm going to want to move my y's to the left and my x's to the right. So I'm going to times both sides by dx. And then times both sides by y. Whoa, wait, Mayday. Okay, just so you have the original problem. We doing okay? Well, so if I'm trying to find what y equals and get rid of the derivatives, the d, then I need to apply the inverse. Just like if I had an x plus 2, I'd minus 2 on both sides, right? You apply the inverse to get a variable alone. Is that fair? So next thing I'm gonna do is I'm gonna integrate this side so that these will cancel, right? So that I'm left with a y, well, not just a y, but I'm trying to get the y alone eventually. And if I do it to one side, I gotta do it to the other side. Okay, so the first thing I did is I separated my variables, and then the next thing I'm gonna do is take the antiderivative of each side individually. Okay, so I have y squared over 2 plus c equals x squared over 2 plus c. Are those c's gonna be the same?
Not necessarily.
Not necessarily, they might be. But do you guys remember when we were first learning integral properties and I would split an integral over addition or something, and we had this conversation about, like, do you need more than one? The same idea is here, right? I could minus this over to combine like terms or whatever, but in the end, remember, c is just some arbitrary random number, right? So I don't actually need a plus c on both sides. I just need one. And since in the end, I'm gonna be trying to get the y alone, right? I would always want to put the c on the x side. I don't want to put more by the y if I'm going to try and isolate the y eventually. Does that make sense? Okay. So you never need a plus c on the y side as long as you have one on the x side. It counts for both. Now what would I do? How? Multiply by 2. I'll take that. Why didn't I distribute the 2 to the c? Yeah, I mean, technically I did. It's just a random number. That's what the c is representing, right? Okay. What do I need to do now?
You need the
Square root. Good. Okay, square root, and I want you to write your final answer. And then I'm going to write it after you write it to see if I tricked you in your algebra. Careful. Careful.
Wait.
well, the square root of c is just a c.
We'll see. See if you can figure out how to write it.
Necessarily, right? Because if it's some
Oh,
random
wait, hold
number
up,
that
hold
can't
up.
be square rooted,
Oh.
then you can't bring it
It
out.
always can be.
Wait, so it's y equals. No, but wait, if we're
20 more seconds. This is the last time you can leave class today, Chase.
I got a really bad headache yesterday, so I'm just going to go.
Okay, Chase.
Yeah, that's where. Yeah, so
did not
just
put on his outfit.
so you just
No, he barely put on his school pants.
which is still just a number.
Reminds me of combo deal school principal.
Okay, there's two little things. There's two little things that might have gotten you on this one. Y equals plus or minus. Did anybody do it? Yeah, Daniel?
I read it.
You saw me write it.
The plus c is not just on the end. Here's the difference between when I times it by 2 and the square root. When I times it by 2, the idea is that I actually did, but a random number times 2 is still a random number. I can't put the plus c on the end because then I'm breaking an algebra rule. The issue is not the c, the issue is the plus sign.
I called it.
Right? You can't split a square root over a plus sign, right? So it has to stay in the square root.
I didn't think of that, but I did that.
Well, good. How are we doing? Okay?
Yeah.
So this is still a general solution, right? It still represents every infinite possibility. Okay? Are we doing all right? Can we do another one?
Yes.
Wait,
Okay, yeah.
it's really confusing. So, for the derivative, y can't equal 0, right?
One more time.
So for the derivative, y can't equal 0, right? Because then it'd be divided by 0.
So that's probably going to be accounted for with the c. So 0 is probably not going to end up being in the range of this function.
Okay.
Does that make sense?
I guess it's just c can be any number, right? So
Well, yeah, but that doesn't mean x and y can be any number. C could be any number. So the one that actually ends up working here, right? Well, and the idea isn't that y can't be 0. The idea is more that when y is 0, my slope is undefined. So this actually graphs as a circle. So a circle's continuous at every point, but when the y coordinate is 0, I have vertical lines here, so their slope is undefined. So y could be 0, it's that it doesn't have a slope when y is 0. Does that make sense? Yeah? Okay. All right. I've never used this program before. I don't know how to get a next page.
Wait, Miss Summers?
Maybe this one? Yeah.
Can you just tell me, like I can understand, like, all the steps and everything. I just don't really get, like, what we're trying to do here. Like, what?
Okay, so you know how, like, on the front board or on our warm-up today, we went through and we did the implicit differentiation. I'm trying to talk and write at the same time of this. Right? Equals 0. Then I minus that over and undistributed the dy dx, and I end up with dy dx equals negative y over x plus 2y, right?
Yeah.
Okay, what if I gave you this originally and I asked for y, or the original equation?
So you're just doing it back.
Yeah, we're doing the inverse of implicit differentiation.
Okay.
Does that make sense?
Yeah.
Okay. Okay. No, that's not right. New page? No, that's not right. No.
I can't wait to watch this video back.
I know, right?
No.
Like with the arrow? Yeah, with the
Wait, can
arrow.
you just, like, erase everything?
No, not that one. No, not
I guess I just erase it all. What does this one do? Or this one? Oh, that, okay. Well,
the one that has 2, is that just a copy of it?
the one that has 2.
Okay, so like there's a little folder that is this recording.
I won. Okay. Okay. Let's try another one. First thing I need to do, separate my variables. So I'm going to divide by y. And multiply by dx. So far, okay? Okay, so now I'm going to integrate. ln absolute value of y equals x squared over 2 plus c. If you don't think you could get those antiderivatives without my help, you need to work on that. Okay? Heck yeah.
Can you just look up, like, will it have practice? Or just like,
That's how I find your practice problems. I just Google it.
okay.
I also know that on AP Central they have practice problems too you guys can download. Another one of my students has been downloading the practice problems from AP Central on his iPad so that he can just do them right there, like FRQs and stuff. So there's ways you can do. Okay. Now what? Yeah, raise everything to the power of E.
Oh, to get rid of the L. I was like, where are you getting?
Yeah, I was like,
I thought Y was by itself. I was like, why would we do that?
Because it's fine.
E to the second. E to the X squared over 2 plus
I don't like
Okay, guys and girls, up here, please. Shh, 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 shh. So, there's one thing you guys are gonna like that I'm gonna do next. Technically, I'm gonna do the step first, and then I'm gonna show you like where it came from. Okay? Technically, this is the same as this. So here's the idea. This here, using my properties of exponents, is like this. And for the same reason, when I times c by 2, it's just c. E to the c is just c. Yeah. Because leaving it like this and not moving it to here, mathematicians consider to be redundant. Because a random number, e to some random number, is still a random number.
Okay. Yeah, guys. I see you. I see.
So you basically like get rid of the E, but like it's still like.
It's there, but it's like e to some random number is still just a random number. Yeah. So I wouldn't even write these out as the steps, just kind of, hopefully eventually you'll see enough of these, right, to realize what's going on. How do you cancel out an absolute value?
Plus or minus?
No? Well, kind of. I mean, you can't. It doesn't have an inverse. So we split it into its positive and negative, right? But for what we're doing for right now, it's okay to just leave it like this. We can consider that alone. But we'll split it into a piecewise once we get to particular solutions in about 5-6 minutes.
So they won't necessarily say if they're giving you one or the other. You'll just like be like, oh, I have enough information, so it's a particular.
No, they will tell you. It will say either general
Okay.
or solve the differential, which is what we've done, or it will literally say the word particular solution, and it'll give you an initial condition, like which is a coordinate point. Yeah.
Will they ever give you enough information for a particular and then have you do a general?
Maybe, because I don't want to talk in absolutes, but I don't think so. I've never seen that. In case you guys didn't hear the question, for those that I'm recording it for, the question was, would they ever give you the initial condition but ask for a general? I don't think so, and I've never seen it, but I have a hard time saying for sure yes or no in calculus because I just never know. So I don't think so. Okay?
Maybe they'll give you like a range.
No, they'd have to give you a particular one. Okay, I'm gonna give you guys one to try on your own. Okay? And then we're gonna move on to particular.
Never mind. Oh, LN.
No.
I tried. I give up.
No LN yet. Not for a while. Close.
It's the times. Oh, multiply.
Okay. What the heck is this? I'm going to give you this first step.
Hey, look at me go.
Okay, my next hint is you will need use substitution on this one, so be careful.
Wait, what do we do now? Times 1 over e to the y. Also
1 over e to the y.
okay.
Because that, wait, no, that would get rid of it.
Wait, so now you got
Wait, I'm sorry.
Oh yeah.
So,
We make you would be
you would be e to the y. And then multiply by dx.
okay.
So e to the y to the negative 1. E times y.
oh, that makes it way.
Oh.
Okay. I was like, I don't want to do it.
E to the negative y. Yeah.
Wait, but
Times
not
dy
the
is
same.
not to e to the x dx.
Yeah. So now we anti-derive that. This is just power rule. Or do we use it?
You don't know my power
Is that one for e? What is dy and then e to the x plus c?
That's as far as I got.
As far as I have on the board is as far as you got? You mean that's as far as I got?
No, I got that first.
Oh, wait, what?
But it's not as far as I will get because I am very good at algebra.
I agree.
But since it's e to
I
the
wish.
y.
I mean, I'm not trying to brag.
So it's just negative.
Liar. It's like you guys like chemistry.
So every time I say that, have you guys seen Secret Life of Pets too? There's a part where the bunny
Oh, so we need to use
is
L.
like after they've saved the tiger, he's walking around. I'm not even trying to brag. That's just what happened. See, that's what happens when you're awesome. You just see what happened and it sounds like a brag. Like funny when Kevin Hart says it.
What's the derivative of L negative 1?
What's your U?
Negative
What's your U? Negative Y. Good.
The question is why?
Because that's the function that's plugged inside the other one. Did you really have that question or you just wanted to say that pun? Yeah, I get it.
So you found the derivative of the e to the x, right? It's just the same thing, right?
So e to the negative y is the same thing as that though? Like is it e to the x or e to the
No.
negative x?
So you just need
Or does the y stay the
substitution.
same?
Okay, wait. So I'm kind of remembering right now, but the u is going to be negative y, right?
Yeah.
And so du is equal
So
to
only
the
that
derivative
side
of
can you
this.
anti-derive first.
Yeah.
Okay. So you're doing your substitution on one side and then you already anti-derive.
Yeah.
Okay.
That was said perfectly.
Oh wait,
What's 1 times
does that mean you actually equals?
Negative 1.
I love how we just like.
Is there any questions so far? Is there any questions so far?
Oh, it's section 1. Yeah.
How would you do it otherwise?
Negative dx
dx.
If you don't, then you'll probably end up with e to the negative y. That's what most people do. Instead of negative e to the negative y, which is its antiderivative.
So why is the negative?
Wait, so du is gonna be.
Because of you and
Because of the u substitution. So
Is it
du
the same thing as
equals
like that K
Yeah,
rule?
because if it's just
a k rule.
I don't know.
then it's
I mean, sure. If I don't know if I wrote the k rule down. We might have.
so it's just
So you
negative
do
dy.
and you multiply by negative 1. So
Well,
du
well, what she's saying is we're
negative
gonna,
1.
if we take the e, that makes it a negative
Then, because then that'll make
Negative
this
1
negative
dy.
negative.
So I had a negative in there to go with the u substitution. I mean, you have your rules good enough to know that the integral of e to the negative y is negative e to the negative y. That would be great. I love that, but most people barely have this integration rule memorized at this point. You think I'm wrong?
I just feel attacked.
Well, okay. If you're taking that personally, then we'll probably you. Hey, you guys, the reason I stopped here is because I got a question. What's next? No, you cannot take the ln.
You do use substitution on one side and then anti-derive, and then after that, aren't aren't you gonna, wait, never mind.
I gotta get the y alone. Sid said ln, I said no. Have to divide both sides by -1 first, or else you can't, and then you can ln. Good Carrie.
Oh, wow.
Algebra. Gotta love my algebra. Okay.
Okay, so you cancel the negative and negative.
Wait, don't you have to multiply the answer as well?
Yeah.
But what?
Terry, you're like,
The ln and the e canceled on the left. Do they cancel on the right? No, because of the plus c. Very good.
Bro, the plus C just doesn't give a crap.
They don't care.
I'm right.
wait, that's so cool.
Wait, Miss Summers? So why when you went from this step to the ln step, did you get rid of the negative on the e to the negative y? Because it used to be negative to us and then
That is still negative to me. It probably just connects.
no, on the top where the arrow goes.
Oh my gosh, I love typing as
Because I divided negative on both sides. It got sucked in here, but it's there.
Oh, okay.
Okay?
Yeah.
Okay. So now, guys, listen. Quiet, please. Guys. So that's general solutions, okay? The tricky part of that stuff is going to be your order of operations and your algebra, right? Algebra, okay? Now what we're going to do is we're going to take it another step and we're going to find a particular solution. So instead of all the infinitely many possibilities we can graph on our slope field, remember on our slope field day, I had you take a guess given the 0.01 what the particular solution would look like, right? That's what we're going to solve for now is a specific equation. But again, the only way I can find that is if I'm given more information, okay? All right, so here we're going to say, let's say I have dy dx equals, have we done a,
No, we haven't.
okay.
Do not listen to Daniel.
That's actually what we're doing next time.
Oh. Stop. Why didn't you just solve the integral and then? I guess we'll find out next time. Stop cheating. You're so prestige. You're ready for the next one. I think.
Okay. Okay, we're going to work through this together for time. Okay? And then I'll have you try some on your own.
Given y is 0. Okay.
All right. Guys, listen. Shh. We're going to work together. Okay, so the very first thing I do is separate my variables. Just so you guys know, when you do these problems, they're like always 5 or 6 FRQ points. And every single time at the bottom, there's a note and it says max points of 0 if no separation of variables occurs. So the first thing you got to do is separate your variables every single time. Okay, so on this one, it's going to look like this. We doing okay?
Wait, why couldn't we do the other one by X?
Um,
Does it matter?
It does, because then I would have my dx on a denominator, which means it's not going to cancel with the integral. Okay? So now I'm going to integrate.
Wait, so Miss Summers, I was gonna point just for doing that.
Yep.
That's crazy.
And then the next points are usually like 2 points for each, and like 2 points for any derivative. So it's usually 1 point for the right antiderivative on the y and 1 point for the antiderivative on the left. Right.
You can get a lot of points even if you end up getting it.
Yeah, because they're making sure you know what you're doing, you know? Okay.
It takes forever to grade.
Exactly. That's why it takes forever to grade. Okay, I'll do this side first. This is the easy side. Power rule. Nope. Well, not yet. It's a U substitution. What's my U? There you go.
It's almost like you have practice doing the problem.
So I put a 2 in there so I could substitute, right? And then a 1/2 to balance it out. We're doing okay?
The fact that you guys are like this and you still understand what's going on.
Wait, why is it absolute value? Oh. Gotcha.
Now I want you to stop when you get to this point.
Oh my gosh, that's the part I stopped on.
Hooray!
Where she said stop.
Okay, you guys, Taylor and guys up here. So here's the deal. At this point, instead of getting y alone first, I prefer if you solve for c first. Here's why. If I get y alone and I do it incorrectly, then not only am I going to get a point for y being wrong, but I'm going to get the wrong c value, right? So I prefer if we solve for c right now, when we haven't done any like solving yet, right, for y, because then even if you do mess up the solving for y, you're more likely to get the c value right. Does that make sense? So I always want you guys to put in your initial condition points right now. So I need to solve for c. So I'm going to put in my, oh, can you guys just, sorry, I meant to, these are supposed to be switched. It only works out nice if I make the y 0.
I'm never writing anyone down.
Well, then don't write in pen.
I write in pencil.
Then you should be fine erasing something. Cry me a river.
Maybe I will. Oh no.
What's the natural log of 1?
Oh, it's 10.
Zero. Boom, baby.
I knew that.
Boom.
Wait, it is? I have forgotten all of this.
Pretty cool. Pretty mad. Pretty fucking fresh. Yeah.
Is this calculator portion or is it?
No way.
We can actually find C.
So now I plugged in C, and I'm going to solve for Y.
You're crazy. You get rid of the 1/2.
How do I get rid of the 1/2?
Multiply by 2.
Multiply everything by 2. Is that good?
Yeah, sure.
I mean, I guess if you want to.
We're doing that by one.
No.
Oh. I guess.
No.
Like, does that mean there's like?
I mean, I guess.
I'm multiplying by 3.
12 pages of just words.
Heck yeah. Good. Now what? E. See, I really want a new page. I don't want to delete this yet.
Well, don't get, because I haven't written it down.
You got a button below the X, like on the black part.
Where's the X?
Up in the
Up
top
in the
right
top
corner.
right, below it. Yeah.
There's a button below it.
Yeah! Winning. Okay, we'll get it to this point here.
See, guys, I'm a genius.
Genius.
Roll.
Does anyone have any questions so far? Because here's where the algebra is going to get a little more interesting. Now we have to deal with the absolute value. Okay?
Why can't we just
This time we can't. Because we're looking for a particular solution that's not specific enough. Guys, stay with me. Hold on. Stay with me. Okay, I'm going to recopy what I have here. Just right here. And it's E cubed over 3 plus 2/3, right? Okay.
Wait, was it so she distributed? No. Oh,
Okay. So guys, listen. Every time I've dealt with absolute value with you guys this year, whether it was limits, derivatives, integrals, continuity questions, it didn't matter. Anytime, I've been trying to drill in your brain all year that anytime you deal with absolute values, you split it into its piecewise. Is that familiar? So we need to do that even here, okay? But here's where it's going to get weird. The piecewise is going to be split around a range, not a domain, okay? So here's what it's going to look like, okay? It's going to be 2y plus 1 equals this normally. For y's greater than or equal to negative 1/2. Where does that come from? Yeah, it's what the absolute value equals 0. Yeah. And then the negative version of that for y's less than the negative 1/2.
Wait, why is it that again?
The negative 1/2 is what makes the input of our absolute value 0. Now, the initial condition point I gave you, I don't remember, was y to the negative 1 equals 0. So do I want the positive or the negative?
positive?
Is 0 less than negative 1/2 or bigger than negative 1/2? It's bigger. So this one here, the bottom one, is representing our extraneous solution. You guys remember that word?
Yeah.
Extraneous solutions you dealt with last year in Sec 3 when you would have like rational functions and you'd solve them algebraically, and one of your algebraic solutions ended up being one of the restrictions, one of the divide by 0 errors, An extraneous solution is one I can solve for algebraically, but when I plug it back in, it doesn't work. So on this one, the bottom half represented my extraneous solutions. That means the top one is my answer.
Like that's the whole answer?
Well, y is not alone yet. But now I can either the 2x cubed over 3 plus 2/3 minus 1 over 2. Do I need to do something about that fraction over a fraction?
No, because they don't.
They don't care because that doesn't count as a fraction over a fraction, right? Because the first fraction's in an exponent. Yeah.
Also, I wouldn't do it anyway.
Yeah, fair enough.
If I got this answer on the test,
I know.
I would
right?
not mess with
You guys doing okay? We ready to try another one?
Yeah.
I want you guys to try one. Hold on.
no, don't do that.
I want you to try one on your own. Quiet, please. Okay, this one I got from an AP question. So I'm going to write the year and stuff there so you can look it up later if you want. It's AB 2005, number 6. Okay. We don't really have time for the slope field part. So I'm going to write the other part. Okay, so part B says find particular solution of dy dx equals negative 2x over y given y of 1 equals negative 1. And then part C, you do?
Yeah.
Ah. All right, we'll walk through these in about 6 or 7 minutes. Okay. Part A on this one is just a slope field. It's great for the practice later if you guys want to write through that. The other thing is that you can take a picture. I'm going to send the picture out too. But here's kind of like a step-by-step list for particular solutions. Okay. You're going to text out or put it on Canvas?
Text it.
Okay.
As you read your text.
Okay, so about 5-6 minutes, and then I'm going to go through these real quick. Okay? And then your homework tonight is an FRQ worksheet.
You have to open it. So,
Sure.
Our work is always like so weird.
and it makes no sense to us. But
What I'm afraid of too.
Usually yes, but you'd have to talk to your college person to know for sure. I don't, it depends on the college, it depends on what your major is going to be, it depends on a few
Sometimes you
things.
have to go past.
Yeah.
So I'm just talking about below AB
Usually yes, but again, it depends on the college. I can't definitively answer that.
Ivy, that's just the schools are very strict when you have to do more.
Oh wait, yeah. We need to multiply y and the x. Y.
It's not an IG.
Anna, is this your book or mine?
It's fine.
Do you want to find C?
That's what I was thinking. I was about to leave.
That would have been bad. Thank you.
So then you put it back to it. So when you get your C, you get
Look, if it's y dy, then that's just the derivative of the integral. Right? So
Oh, it's the one, it's y squared over x. Yeah, that's what I thought. It's the anti-p, not a derivative.
Oh yeah, we don't have to do these. Yeah. Wait, what is it? Y squared over 2?
Wait, but then that would equal
Equals negative x squared.
Technically, we can like show
it would be
Shayna, what'd you get?
You're stretching out.
Sorry, I want
right?
May I send to Reman to attendance for checkout, please?
Sure, thanks.
What's the point of this?
Because I have to go to.
Yes,
Where are your thingies?
That's it.
On the
They
bottom
use things to do this.
of this graph.
I think actually
They already gave us the first one, so, but it's like, and
I've heard,
because like
so all of us. Like this is x.
That's y.
because my left eye would be a little up close and far away, my right eye can't do anything about But no, I'm like,
What is that?
Let me just, actually, they were like, this is what was the fucking lens, and I was like, yeah. It was insane. I was like, everything's so clear.
You guys doing okay? Do you need
Yes.
more time or what's going on?
Amazing. I did that part right. Yes.
Oh, and on this side, so after you derive it, it's still 1. So we already know it. Okay. So then this one is just,
See you guys.
is it just negative
Bye.
squared
Yeah, it's -2 squared. Do that, so it'd be negative x squared.
I don't get the approximation big though. That I
I should see your name. I'll send it.
Wait.
So the process y.
Oh!
Oh wait, but we don't have to write it on the
It
y.
doesn't. I just think
Negative x squared.
Okay, we just need 1 plus c, right?
I don't know. So that's
I don't have to do plus c on this side, yes.
Yeah, you just do plus on the
x side.
that's what I said. That's what
Oh, that's how it is. So like, after you
Hey guys, I know you don't have enough, you haven't had enough time to finish it, but we only have 4 minutes and I want to go through it. Okay. So, for the B, it was dy dx equals, was it 2x over y? So y dy,
I mean, it's probably not supposed to.
Oh wait, we were supposed to find the C a long time.
wait. The 2 and the over 2 should cancel, right? Okay, and then this is where I want you to put in your initial condition. So it was y of 1 equals negative 1. So negative 1 squared over 2 equals negative 1 squared plus c. 1/2 equals negative 1 plus c. So c is 3/2. Anybody so far so good? Hooray! I don't feel like dealing with fractions, so I'm going to times everything by 2. Like magic. Square root, plus or minus, but we have enough information now to figure out which one it is. Is it the plus or is it the minus?
It's the
Plus. It's the minus. It's the
Oh no, it's the plus
the
because it
minus.
says
one point one.
It's the minus.
Oh, because it is
Plus.
negative.
The y is negative. It's the negative.
That's what I said.
Wait, so you look at whatever the y is,
Ew.
and then it's like since this y is negative 1, you use the negative 1.
Yeah, because look, if I plug 1 into here, I get negative 2 times 1 plus 3, that's 1. I can't ever get a negative number out of a square root. So if my initial condition is a negative, then it's got to be the negative version of the square root, right?
Yeah.
Okay, are we doing okay? Okay, part C was really easy if you got to try it. It should have been y plus 1 equals, we plug the 1, negative 1 into our dy dx. So that would have been negative 2 times 1 over negative 1, so that would have been 2. So 2x minus 1, and then you put in 1.1, so y plus 1 equals 0.2, so y would equal negative 0.8.
So y plus 1.
It's y minus y1, and my y is negative 1.
Oh.
Good work. Homework is a worksheet. I already gave it out. Yeah.